Magnetic force. The sky is overcast with thick clouds. A storm is coming in. You and your friends have been trying to find your way back to the ranger station for an hour. Whose idea was it to go off the trail? That clump of rocks looks awfully familiar. You're pretty sure you are going in circles. If only you had brought a compass to show which way is north. Fields of force. When you are using a compass, the tiny magnet in the compass needle aligns with Earth's magnetism and helps you find your way. But closed in its plastic case, the needle never touches another magnet. How do magnets exert a force without touching? It is similar to how a falling apple and Earth exert a force of gravity on each other. Both the apple and Earth have a gravitational force that extends from them because of their masses. It forms an invisible gravitational field. Like gravity, magnetism is another invisible force of nature. Magnetism extends out from a magnet into the surrounding space to form what is called a magnetic field. Force of attraction or repulsion. You feel magnetic force when you try to separate two magnets that are stuck together. You also feel magnetic force when you push two magnets together and they push away from each other. Magnetic force makes magnets act the ways they do. The magnets used in class are permanent magnets. They exhibit magnetic properties pretty much all the time. Every magnet has two different sides or ends called poles, the North Pole and the South Pole. A simple bar magnet has its two poles on opposite ends. A horseshoe magnet has a pole on each end of the horseshoe. The donut magnet you worked with have poles on the two flat sides. What happens when you hold two magnets close together? They exert a force on each other. But will they attract or repel? It depends on how the poles are oriented. Below are 4 pairs of bar magnets being held together. Which ones will push apart when they are released? The diagram above shows what happens when the magnets are released. 2 general rules apply here. Can you figure out what the rules are? The 2 pairs of magnets on the left attract each other. The 2 pairs of magnets on the right repel each other. 2 north poles always repel each other. 2 south poles always repel each other. We can state a general rule, like poles repel. A north pole and a south pole always attract each other. It does not matter which magnet has the north pole and which has the south pole. We can state another general rule. Opposite poles attract. How magnets stick to iron. If opposite poles attract, why does a magnet stick to a piece of iron, like an iron nail, that is not a permanent magnet? Remember that magnetism extends out from a magnet in an invisible area called a magnetic field. When a magnet comes close to a piece of iron, such as an iron nail, the magnetic field interacts with the iron in the nail. The nail becomes a temporary magnet. The end of the nail becomes one pole of a magnet. The magnet then sticks to the temporary magnet. So magnets do not really stick to iron. Magnets stick to other magnets, even if they are temporary. The temporary magnetism in the iron is called induced magnetism. Induced magnetism happens only when a magnet is nearby. Take note. What are some examples of induced magnetism you observed in class? Particle properties. To understand why some materials have induced magnetism and others do not, we have to explore the properties of magnets at the particle level. That means at the level of atoms and molecules. We can can start to think about particles by considering what happens when a bar magnet breaks. Do you have a magnet with just one pole? No, both pieces still have a north pole and the south pole. The same is true for all other magnets. No matter how many pieces you cut a magnet into, each piece still has a north pole and a south pole. Each magnet piece has poles lined up in the same way. If you did this a million times until you had the tiniest particle of the magnet that was still a magnet, you would see that each particle has poles lined up the same way. This property defines a permanent magnet. Each particle has the properties of magnetism. Here is an illustration of a magnet being cut into pieces. As the particles line up, each tiny magnetic field adds itself to form one big magnetic field. Non-magnetic materials. All non-magnetic magnets can be split into two general categories: magnetic materials and non-magnetic materials. Magnetic materials, such as the elements iron, nickel, and cobalt, have magnetic properties at the particle level. But the particles are not all aligned the same way. Those particles can line up when they are in a magnetic field. The particles become a temporary or induced magnet. Non-magnetic materials like plastic do not have magnetic properties at the particle level. Those particles are not affected when they are in a magnetic field. Here are two illustrations: materials outside a strong magnetic field and materials inside a strong magnetic field. If you bring a strong magnetic field close to a magnetic material, the particles in the material will line up with the magnetic field. They create weak temporary magnets. Particles in the non-magnetic materials will not line up, so even the strongest magnet cannot attract or repel a material like plastic or wood. Think questions. What rules determine whether magnets will attract or repel each other? How can a magnet attract or repel another magnet even if they are not touching? And if you bring the south pole of a magnet close to the head of an iron nail, what changes will happen to the iron particles? We are now done with this chapter.